Alright, in this video, we're going to kind of review what mean absolute deviation is and how you calculate it. So again, what exactly is the mean absolute deviation? And again, what it is it's the average distance between elements in a data set and the mean. So if I give you an element, you can tell me, based on the mean absolute deviation, how far away from the mean is it going to be? There is a formula for it, but you don't really have to get all caught up on what it is except for the process on how you do it. So again, what is the formula? Alright, so we have this weird summation formula, and again, what this formula means is this big uppercase sigma means you're finding the sum, because when you're finding the mean absolute deviation, you have to add a whole bunch of things together. Alright, so what I have is the sum of, and then my underneath of I equals 1 means I'm starting from the first element, and my n at the top means I'm going all the way to the number of elements that there are. And what I'm adding together is I'm adding the absolute value of every single element minus the mean, adding them all together, and then taking all of that and dividing by the total number of elements, because we're talking about a mean, which is another way of saying average. Alright, what we also want to take another look at is, well, what are the steps for calculating the mean absolute deviation? Because there's a whole bunch of different stuff going on, so we need to break it down again. Alright, and what those steps are is, the very first thing you have to do is find the mean, because once you find the mean, you have to take every single element in step 2 and subtract every element minus the mean. Alright, but then what you have to do, because if you don't take the absolute value, that sum will always be 0. So in order for it to not be 0, in step 3 we're taking the absolute value of all of the answers you got in step 2. Alright, but again, we're talking about the average, so that's why in step 4 we're going to take the sum of all of the values from step 3. And then again, since we're finding the average, we have to divide by the total number of elements. So in step 5, we're going to take that sum we just found and divide it by n, otherwise known as all of the numbers in our data set. So let's take a look at another example so you can kind of see this done one more time. Alright, so what we're going to do is we're going to find the MAD, otherwise known as the mean absolute deviation of the data set 0, 2, 2, 3, 6, 7. Alright, so again, what I'm trying to do is I have to find the mean, and I'm finding the average distance that each element is away from the mean. So the very first thing we have to do is, in step number 1, we have to find the mean. Alright, well, the mean is equal to the sum of all of my numbers, and when we add up all of these numbers, 0 plus 2 plus 2 plus 3 plus 6 plus 7, we're going to get 20. And then we're going to take 20 and divide it by 6. And when we take that mean, we're going to get 3.3 repeating. But we're just going to go ahead and round that to 3.3. Alright, so now in step 2, what I have to do is I have to take every single number in my data set, so every element, and subtract it from the mean. So I have to do 0 minus 3.3. I have to do 2 minus 3.3. I have to do 2 minus 3.3 again. I have to do 3 minus 3.3. I have to do 6 minus 3.3. I also have to do 7 minus 3.3. Alright, so now I'm going to go in and do all of those. So 0 minus 3.3 is negative 3.3. And then 2 minus 3.3 is negative 1.3. Again, 2 minus 3.3 is negative 1.3. Then I have to do 3 minus 3.3, which is going to be negative 0.3. I have to do 6 minus 3.3, which is 2.7. And then I have to do 7 minus 3.3, which is 3.7. Alright, now what step 3 tells me to do is I have to go in and take the absolute value of everything, because if I don't, when I find the sum, all of the sums are going to come out to 0. So I have to take the absolute value to prevent that from happening. So the absolute value of negative 3.3 is 3.3. The absolute value of negative 1.3 is 1.3. The absolute value of negative 1.3 is 1.3. The absolute value of negative 0.3 is just 0.3. The absolute value of 2.7 is still 2.7. And then the absolute value of 3.7 is still 3.7. Alright, so now what step 4 tells me to do is I have to go in and find the sum. Alright, so remember the sum has this notation, so I can say the sum of all of my absolute values is found by adding them all together. And when I add up 3.3 plus 1.3 plus 1.3 plus 0.3 plus 2.7 plus 3.7, I get my sum is 12.6. So now in step 5, I have to do my sum divided by my total number. And when I do that, I'm going to do 12.6. And I'm going to divide by 1, 2, 3, 4, 5, 6, because there are 6 of them. And 12.6 divided by 6 is going to equal 2.1. So my mean absolute deviation is 2.1. And again, what that means is when I get my mean, which in this case was 3.3, the average distance every single element was away from the mean was 2.1. Now, does that mean every element is 2.1 units away from the mean? No. What it means is it's the average distance every element is away from the mean.